Okay, good. I check the situation. So you see that we have a textbook. You can see my camera or not, or only the screen?
Only the
You
screen,
see?
sir.
Oh, only screen. Okay, next time I check it. So it is some problem. So you see it here, two textbook. The second one, this one is some years ago when I wrote some note for the advanced program, and this one have the note and also the problem for student to do it, and they tie it into so-called lecture notes and problem. You can find it in library. Some years later, publishing publishing house publish it in the book form, so it is better for you to read. However, in the book form, it is they are not include the problem. So both, if you can go to the library, so borrow these two things, lecture note, and they tie it with the problem also, and the second is the book form. Okay, I don't know why you cannot show the the camera. I'll check the problem later. So, but somebody use it because we are using the English. So there are some references because they are very famous English textbook for engineering mechanics of the author Hibler, Miriam and Christ, and also Beer Johnson. But they are big books. Maybe for student it is too big. So it is better if you can read the textbook. Is a small one. I have already prepared for you. I use all these three and other as a resource for writing the, the textbook for you. Okay, so after finishing the situation is the COVID-19, you can go and borrow it. But remember well, next at the end of the presentation, somebody asked again. Tomorrow, not today, I will post the problem and some portion of the lecture notes and also the slide, today's slide on the team. Okay, you can read it and study it again with the slide and the lecture note, some portion, because I don't post so much. You can read it step by step and also start to solve some problem. Okay, on the team. I'm surely that for somebody who come today later and at the end of the presentation, they ask again that please professor send us again the slide or so on. So remember them that all every necessary things you will have on the team. Okay. So before going to the first chapter, only for your information, I show this picture for you many times later. Because you see that on the title here, we have engineering mechanics. It is really the basic, basic, basic science for other science for machine, and also we do want to explain why the machine function, why the car can move, why anything. So this is so-called engineering mechanics. And in engineering mechanics, normally over the world, we have the two parts, static and the dynamic. Static, we will study in this course. In the first semester. In the second semester, we have the dynamic. Okay, and the dynamic will split it in two other parts, kinematic and kinetic. I will explain it more in detail later today. But here at this first slide, I only show you that you will do or we will have together two semesters. First one is a static and the second one is a dynamic. Why? The topic of the mechanics is try to find the relationship between force and motion of rigid body.
Excuse me, sir. Your microphone is muted.
We cannot hear you, sir.
It's better? It's better?
Yes, just sure.
Yes, we heard you now, sir.
So at the beginning, I asked you if you hear well, so everybody says that it's okay.
Yes, but someone has muted you, sir.
Oh, so somebody mute me. Oh, it is too bad. I forgot it. Okay. Okay, I will check it. So okay, so maybe somebody mute me. Now everything is okay?
Yes.
Yes.
Okay, I write it again. Oh, it's okay, right? So I don't know if I said many things about. I say many things about the about reference in books. I need to repeat it again or not? About reference about textbook and also.
No,
Okay.
no, no. You are telling about the dynamic and kinetic and kinematic and
Okay.
kinetic.
But some minutes before, I mentioned about the textbook and references. Did you get anything? Okay.
Sir, please could you repeat from the differences between statics and
I cannot
dynamics?
I cannot hear. I cannot catch you.
Sir, could you please repeat from the problems from between statics and dynamics?
So I repeat it again. So tired for you.
No,
Okay.
not from beginning, sir. Just the differences between statics and dynamic. It's where your voice dropped.
So you know that where you can find this textbook. Okay.
Okay.
Okay. So. Oh, Mr. Osama, yes, please repeat. Okay, so Mr. Osama require repeat again because only one foreigner student here in the classroom. I say that we have this textbook and also the problem. I will post it on the on on the team later, even with the slide, so you can find it. Okay, and you can go to library to get these two textbook and lecturer know also. Normally, it is better to get also the problem here because you can do the problem and send me the solve the problem. It is better for you to train it during the course. Okay, but there are many good English book also. However, they are too big and too so much for you. So it is better to read these two sources. But some Vietnamese student use the Vietnamese textbook also, but pay attention because it is maybe it is not the same at our course. Okay. So, but you can use this. You can use discuss many times with the Vietnamese students. So we can use textbook again. So come back again here. Normally in this course, you have first course static. It means that it is first semester. The second one is a dynamic. It's the second course. But for Vietnamese course, the static and kinematic will be included in the first semester. Only in the second semester, it is a kinetic. Okay, so pay attention. And for other course, even in our university, not for mechanical engineering, they have only one course for mechanics. So pay attention. Okay, so in our university, there are various courses for various students. For our student in advanced course, you have the first one, it is static. The second one is a dynamic. For mechanical engineering in Vietnamese course, they have static and kinematics in the first course, and the kinetic in the second semester. Okay, so for your orientation. And now we come back again to our plan. So the static, we study only equilibrium of the either force system or the body. And in the second course, you will study the dynamic. In this case, you study the relationship between force, force and motion, okay. And force and motion, it means that because in the static you study very much anything concerning the forces, but in the kinematic one you study only the motion without the explaining why. It means that no forces. So in this case, I have the in kinematic only motion and only in kinetic portion here. In this one, you have the general relationship between forces in static one and kinematic in the motion in kinematic one. Okay, it is for your information why and what you will do together in 2 semesters, and how you can discuss the problem with the other student with other specialization in our university. And now we will go to the first chapter in introduction to mechanics, and I will explain it again step by step very carefully why and what we will do it. In this chapter you have you will explain again what is static and dynamic. I mean, repeat it again and explain might be more in detail, but I think that you have already enough information for you. And you sorry in like in each specialization, in each scientific field, you should specify basic quantity, basic law in mechanics. If you have other quantity, you have other laws, so we have another scientific field. Basic law is very important. You know, it's so-called axiom. What is axiom? Axiom is the basic law that we cannot prove it. You accept it only. But everybody can feel that it is okay, it is right. But nobody can prove it. And other law and other thing can be derived from this basic law. And if you use other basic law, you have other science. Okay, so it is very important. Many students and many engineers forget this and forget that why each law and each assumption used in static or dynamic. So you get the very what you say funny result. Surely it's wrong result because they forget what the basic law is in static, what is accepted. Okay, and also I have we have units measurement, numerical calculation, and my problem is that these topic are important, especially in this time. If you remember last week or last month, you do many examination online, and we have a big problem with the numerical calculation, because the machine will make mark for you, will specify how much and only the good result are accepted by machine. So pay attention to this. So in the first chapter, we'll discuss this thing. Okay, and today we go further. But first thing, what is a mechanic? Again, I say that mechanic is the science. It is really basic science for other science, because you will try to find to explain the motion around us. What happened? What of the thing about us, either in chemistry, in machine design, or in anything. You will try to find the relationship between force and motion. Okay, so we say that the body, and in a real language in the life, we say the thing, but it is the body. What happened is the body when the force apply to it. But so okay, so we will try to find the relationship of the motion of the body under action of the forces. Okay, you see here, the force can be very large or very small. The body can move like this wheel, or in the in the rest, like here in the equilibrium. You can try it. You can try to find why and what and how and define it. Okay, if this force is large enough, and this material is good enough, because the force is too big, and after that this will be broken or not. Okay, it is a sense of this science. So you see again, mechanic is a branch of the physical science, and it's try to find the state of the body, either the rest equilibrium or the motion under the action of the forces. You see again this picture. I try it, and just now, after after finding some explanation topic, you see again that I have static, I have dynamic, and dynamic is split it into two parts: kinematic and kinetic. Static deals with the equilibrium. Some minutes before, I say that static deal only equilibrium of the body, which is at rest. But here you see that sometimes they say also that move is a constant velocity. It is right, it is correct. Why? Because today we'll explain it also that sometimes, or with the space on the time, we have the we have a so-called coordinate system, inertia coordinate system. Inertia coordinate system, it means that the system moves with the constant velocity. So if I extend the topic of static, that I say that I will study the situation that are included in the system which are at the in the equilibrium in the rest, or the system move with the constant velocity. So you see that the next portion of the mechanic is a dynamic. You see that even is a motion, but in this case the motion is with acceleration. So you can see that if I have no acceleration, that it means that the motion is with a constant velocity, and the situation or the system is inertia. So in this case, sometime later in the second course, you can explain it more in detail. But at this moment, you can accept that the assumption that in static you study only the equilibrium of the body. Okay, at rest. Okay, and for your information, the dynamic will split it into two parts: kinematic and kinetic. In kinematic, we study only the motion without the explanation why the motion occur. It means that I don't take care about the forces. It means that I only say, I only say that this car have the velocity, say, 5 meters per second and acceleration, say, 3 meters per second square. But why this car has this acceleration? I don't know. Okay, I only measure it. Only in the second portion of the dynamic, I combine the motion in kinematic with the force system we have already studied very carefully. So I study the relationship between force and motion. Okay. So in the first course, I study the static. Everything is in rest. And now we go to the basic quantity in mechanics. This one is very uh, important because you cannot specify anything if I don't know about the basic quantity. For example, I say that I try to find the relationship of the force and the motion. How we can specify the motion of rigid body? You can specify the motion of rigid body only if I have the velocity acceleration. Okay, so velocity and acceleration can be defined by only if I can measure distance or length in the time. So I should know what is the length, what is the time, and the motion of body. We see body can be specified if it's the heavy or is not. You can see that I cannot move so heavy rigid body. It is if the rigid body is light, I can move it easier way. So it means that mass. So you see these basic quantity, space, length, time, mass, and force are very important. What is what? What is the space? I specify the motion, so I should know where. So it means that the geometrical region occupied by body, this body, for this body, I want to specify the motion. So you see this region occupied by body whose position I want to study. So it means that this position described by some measurement, and this measurement is either linear, it means the distance. So 5 meters, for example, this specify, or this building is high, for example, 20 meters. And sometimes the measurement is by angle 50 degree or by radian also. Okay, and because each position of body are specified with the coordinate system, and this coordinate system will specify by parameter by using linear or angular measurement. Okay, so for space should be connected with the coordinate system and specified by linear or angular measurement. Next, length. What is length? How you can specify the position in the coordinate system? You should measure the distance of the point. How far from the origin? So it is length, distance. Okay? And also, how big the rigid body are. So it is a size. So all the time I should measure it by length, by meter. For example, in Vietnam, you use the unit of distance or length by meter. Okay. Time also. How you can define if the rigid body move fast or slow? In this case, the time is very important. So the time is the success or the what you say is the token of succession of event. Okay, and it means it's linear from the history to the future. It means that yesterday is before today, and today is before tomorrow. Okay, you cannot go back to the yesterday. So it means that the time are linear and independent, and it is very important. Mass also. Mass is how the body is big, is heavy or not, and it is with the mass you can connect it. We can compare the action of one body to another. It is very important. It's quantitative. Okay, but many people confuse the mass with the weight. 5 kilogram, it is a mass, it is a scalar. However, if I say about the force, so it means that it is a gravitational force, it is a weight. I multiply it by gravitational constant g. So I have weight, have m times g, and I have force. And sometimes, yeah, you can mix it, but don't be confused. Mass, you can compare the action one body to another. You can use it because, but represent by it by the action of one body is the force. Okay, and the force is a vector. It means that I have a point of application, magnitude, and direction also. Okay, here we have so much, but here I try to emphasize because I say that I want to specify the relationship between length, time, mass, and force. Length, time, mass, and force. For studying the relationship between force and acceleration. And they create really a basic quantity of use in mechanics. You can define it by using the unit. And just now I have one question for you, because for not living and concepting. Listen carefully. I have four quantity. They create a really basic quantity for other like velocity, acceleration, and so on in the mechanics. Do you think that all these four quantity are independent or not? It means that I can define it in any way I want or we want, and after that I can define velocity and these all these four, they are independent or not? Independent or not, I can define it. Okay, we can define it or not.
I think only time, mass, and force are the independent, but length and force they are dependent to each other.
uh, Mr. Tien, again repeat it because I can.
I think only time, mass, and force are independent
Thai,
quantities.
mass, and fox. Thai, mass, and fox are independent.
Yes,
Why?
but mm, because, like you said, nothing can control the time, so time is independent to the
Okay,
rest.
time is independent. Mass is independent also.
Yes,
Why?
so
Okay, good. Good that you have the answer. But okay, Mr. Dat also. This is good that you give the first answer that they are not independent, even they are basis. But how? Why they are not independent? You can explain it later. But good, you have Tien, you have answer not correct 100%, but something is good. You will explain it later. But if you are start to think about this, it is good way. Okay, Mr. Dat also, they are not independent. Why? Why? You will see it later. Okay. You see here, Mrs. Tien, space, time, and mass are absolute constants. They are independent each other. You cannot define space in Newtonian mechanics. Okay, mass also, how big? However, force is not independent of other three. Why? You will explain it. You will explain it. However, You can see that for other. You can specify. You can think that fox is the first one, and I can specify another thing. Today we'll explain it. But at this moment, the good answer for my question is these four quantity. These four quantity: length, time, mass. They are not absolutely independent, and they are couple each other. Okay, so we will see it more clear later today. And now come back again to the basic quantity. You have more other definition. Idealization. It is very important. Why? One important thing for engineer that you should, because you should create the model for solution. The real life is too complicated and too big. You want to understand the nature, mother nature. You want, but how? You cannot understand it. For being to understand the mother nature, you should create some model and try to find the answer from this model. And the model can be complicated or ideal or simple. It depends on the model created by engineer as a people. If you can create a complicated model, it is better. It is closer to the nature. However, you cannot solve it. Okay, you can create a very simple model, so it can solve it. So give you some information, some idea about the motion of this. Okay, so step by step. I take the example, a car. If you want to study in which time the car from Hanoi reach Haiphong to Haiphong city. Okay, so in this case, you can make a very simple model like a particle. So at 8 o'clock, 8 a.m., okay, 8 o'clock, it is at Hanoi. After 2 hours, it is somewhere in Haiphong. So I can take the particle. However, if you want to study how the car is good for passenger, how is comfortable. So in this case, the model of the particle, it is not so enough, not enough for the for the car. In this case, you should create a more complicated. Okay. So in this course, one thing, sometimes in the particular, you need to create a model yourself, like an engineer. You should do it. Okay, and can solve it. And after that, later in with the other science also, you can step by step using the more complicated model. Okay, so with the idealization, you can see something, for example, particle and sorry, and rigid body. A particle, I have already mentioned about this. Uh, what is a particle? A particle is defined. It's the simplest model of the rigid body. Why? Because the particle you can define like a geometrical point with a mass. What is the geometrical point? It means that it has no size, but it has a mass. Okay, so it is a particle. Why it has no size? You see, for example, the car. When I want to study the motion from Hanoi to Haiphong, so in this case, 2 meters of the car, the size of the car 2 meters is too small with the distance from Hanoi to Haiphong. So in this case, I can neglect it. Okay, but next time you cannot neglect it, or it have some influence on in the study of the motion of the car. So in this case, I cannot use a particle. In this case, I should use the model of the rigid body. What is a rigid body? Rigid body is the set of many particles. But in engineering mechanics, I say rigid body, and I understand that it is absolutely rigid. Absolutely rigid. It means that the distance of any particular of the rigid body is unchanged during the investigation, during the study. Okay, so as I said before, for example, for the example of the car, sometimes I can use a particular model, but sometimes I should use a rigid body because I want to study the rotation also, the comfortable of the rigid of the passenger also. So in this case, I should use a rigid body. And remember well that for engineering mechanics or in this course, rigid body is a absolutely rigid. Okay. And next uh, next definition is a Fox system. What is a Fox system? Fox system is very important for us. Anything is a Fox system. By definition, you can say Fox system. Fox system is a system of many foxes. Why? But important that many people forget the second part of this. These foxes should act only on one body. On one body. Here I write it in the red color. On a body. In English, you know that it means that in one body. Why? Fox system is a system of many foxes acting on one body. But you see that in the life around us, we have many rigid body, and the fox can be can act in anywhere. For example, if I take a system of car with the passenger, you see many foxes acting on the passenger, on the car with other. How we can do it? Surely, the fox system theory is a theory solve anything with the assumption that any foxes acting on one body. After that, you will have the way or the extension of this basic theory to the system of many bodies or to other body. Okay. However, in this case, you should accept some assumption. Okay, some other assumption. You cannot apply it in arbitrary way. Oh, in the arbitrary way, if you apply directly the result of the four system theory, it leads to the wrong result. Okay, so remember well that for system, if you don't say anything with no another assumption, all the time think that is a with assumption that all foxes are acting on one body. Okay, and now other other uh, definition. First thing, equilibrium. We say that in the study you study only the rest or the motion or the equilibrium of the rigid body. What is this? So in this case, you should give a definition. You say that a body is set in equilibrium. It does not change the position in the space under acting of the Fock system. Important thing is that equilibrium either that the body is in equilibrium that is does not change its position. How we can see it? So in this case, you should have some space. You define some minutes before that space is connected with the coordinate system. So if the body is defined by some position, by angular measurement or linear measurement, some distance, and these parameter, the angle, the distance, are unchanged. So I say it is a equilibrium. Okay, even under the acting of some Fock system. Okay, so it is a definition. So I say that it's no motion. So it is equilibrium. You see again, one remark. Here, you see that I say a body is said to be in equilibrium. I say about the equilibrium of a body. However, in textbook, sometimes or many times or normally, I say also the equilibrium of the Fock system. Why? Because I say the Fock system, come back again to this one. A Fock system is defined as a system of forces acting on one body. Okay, so you see that if the body is in equilibrium, so it means that the Fock system are also in the equilibrium because they act on this rigid body. Okay, so remember well that if I say that the equilibrium of a body is static, surely, or equilibrium of a Fock system should be the same. Okay, in the meaning in the textbook sometimes. So for forces, there are two kinds of forces: concentrated force or distributed forces. Concentrated force, you know it. Normally, even in physics, I say we have one force F1, we have the second force F2, not forces. It is concentrated force. And in this case, the force have a point of application. And I assume that that the point of application is only point. And the load, even I have some load act on some other body, but the area of loading is too small compared to the overall size of the body. So in this case, I say the concentrated force. The second, the other kind of the forces are or is distributed forces. It means that the load is affected over some area or some volume. For example, gravitational force. You see that each small particle has some gravitational force. And I have the rigid body, same each rigid body has some distribution contribution to this gravitational force of the whole rigid body. So in this case, I can represent the effect of loading over the area or line or volume, even the volume. So in this case, I say distributed forces. Okay, and but normally later in static, the first one, if you can go to the to study the equilibrium and another thing, so I should convert the distributed forces to the concentrated force. Okay, replace the forces distributing over the area of the line to the one concentrated force. Okay, how you will see it. Maybe somebody know it from the physical portion. And now the one important quantity definition also the weight concentrated concern or the connected is the mass. Okay, but by the gravitational law of Newton, you see that any two particle or body have mutual attractive or gravitational, we call it, force acting between them. So the weight is the gravitational force of this particle with our ground. Okay, our ground. So in this case, I have weight. Now, after defining all the definition, now we will go to the very important portion. Pay attention. Basic law in static. Like in other science, each science should have a very basic law. You call it axiom. Axiom are the law of some science which we cannot prove it, but we accept it. Anybody, anybody can feel that it is correct, it is right, but you cannot prove it. And other law, other things can be derived from this basic law. For example, F equal ma, second Newton law, dynamic. You study it in the second semester. Nobody can prove it. Only Sir Isaac Newton, 500 years ago, he stated. Nobody can prove it, but all people, including us, accept it and use it. Okay, if you accept another law, not F equal ma, so we have another thing, in another science. Okay, so the same in the static, you will have six basic laws, six axioms. They give us the tool and the definition and the way to calculate or to study the equilibrium of the body in the action, under the action of the forces. Okay, we do it step by step. First axiom: the force system of two forces in equilibrium, if they are equal in magnitude, opposite in direction, and collinear. What is this? Because you speak so much about equilibrium, so you say, okay, this force system is in equilibrium. Why? Because he says that some minutes before they say that this force system acting on this table, on this car, and this car, it does not move, does not change, so it is equilibrium. Okay, you say. However, your girlfriend say, no, this table is not in equilibrium, because I see that this table move even in very small motion. So this table is in equilibrium. So the force system is not in equilibrium also. So you can have the discussion all the night. Okay. So but the first axiom give you this definition. The force system of two forces. I don't say anything about the motion position, but only I see that if I have two forces, they are collinear, opposite in direction, and the magnitude of these two forces are the same. So I say that the force system are in equilibrium. You cannot prove it. You feel it. Really, if I take one part, you take the ball, and you act these two forces, so you see there's a ball in equilibrium. So you see that we accept this first axiom. Why? I say the basic law, the same, this one is this one. Surely I assume that this one is a rigid body, absolutely rigid. Okay, and if one is not a rigid body, so if I have F1 and F2, deform. Okay, another thing. So the first axiom gives us the tool for defining the equilibrium of force system. The second one gives us the tool for simplifying or changing the force system. You can see that the force system can be here. I have equilibrium of only two forces is the first case. However, I see that I have the case that many forces, too complicated. But how you can do it? First thing, I should simplify. How? One way is remove some force. I can remove some forces if they are in equilibrium. So the axiom say the action of the force system is unchanged if I remove the force in equilibrium. Surely the vice versa I can act also. You see here. If I have this one, for example, a force system with 5 forces, 1, 2, 3, 4, 5. Too complicated for us. And in this case, but I see F4 and F3 are, or they create one force system in equilibrium according to the first axiom. So in this case, I remove it. So in this case, I have a simpler force system. So the second static axiom gives us the tool for changing, or for modifying the force system. Okay, so this is one tool. I have another tool for simplifying. Oh, sorry. Okay, it's another tool for simplifying. This one, I think many people know it. It is so-called parallelogram law, third static axiom. The resultant force of intersection forces can be represented by the diagonal of the parallelogram, which has two element forces at the side. Here, I have the resultant force of intersection forces F1 and F2 by the diagonal FR, which has two element force at the side. FR, why called FR? R is a stand for result. Okay, very important thing for this course is finding the resultant force for any force system. Here I have only two intersecting forces. So this one is a very simpler way. But later, for complicated force, you see that how you can use this third axiom of parallelogram law to the to more complicated form. In other course, I emphasized some years ago, or many years ago, and even though it repeats one case of one engineer, Mr. Thường, okay, Mr. Nguyễn Văn Thường, maybe you read it again in the newspaper for journalists. They don't understand where's the problem. It started many years ago, 40 or 50 years ago. You cannot understand well, and they make some experiment, and he said that this law is incorrect, and many teachers from the high school asked, because Mr. Trần Bình Minh, that time he's in the VTV, he's the director of the one program of the VTV, show it on the TV, and many discussion about it, and many, even the teacher of the physical in the high school very scared, and it is correct or not, and if it is not correct, it is wrong. So please give us the answer to remove it from the education program. Now, after that, even after 20 years, 30 years, and just now some journalists take it and take it again. But I say that it is wrong. Okay, the parallel is okay, and you can use it for studying the static. If I have a time more, I will explain it and tell you more about this story. It is a very interesting. It is from the case that many people spend all the time his life. He engineer Thường, you can call it grandfather, because he too old, spend all his life to this problem, but it wasting of time, because he cannot understand well other thing. So all the time he follows it and give very odd or very wrong answer, or to a very odd result from the mechanics. Okay, and for other things. Okay, it is one history for your not asleep. Okay, fourth axiom, you know it. Two forces acting, action and reaction between in magnitude, opposite in direction, collinear. You know it many times. And in dynamic, you repeat again. And this one is so-called third dynamic axiom, because it discovered by Sir Isaac Newton. It is a third dynamic axiom, but in static you call it fourth static axiom. Okay, it means that two rigid body or two particles are in interaction, and action and reaction should be the same in magnitude, collinear in and opposite in direction. Okay, I think that many body understand well. But now I have the second question for you. Maybe, yeah, you many body knows the answer, but you cannot explain why the answer is such way. My question is, even the foxes are equal in magnitude, opposite in direction, and collinear, but they create the Fox system in equilibrium or not. Okay, do you understand my question? They create a Fox system in equilibrium or not? They create. I have some problem with my keyboard, so normally I write my question on. They create equilibrium or not? Um, System or not? Okay, I write my question on the chat room. They create equilibrium system or not? I have some problem with my keyboard. Okay, so maybe, but you can understand. Yes or no? Yes, they are. Oh, Mr. Osama, where are you from, Mr. Osama? You are from? No. Okay, Mr. Osama, where are you from?
I'm from Morocco, sir.
Morocco.
Yeah.
Okay, so from Casablanca. Okay.
Yes.
Okay, so good. Okay, so come back again. Right? No, no, no. Only one, Mr. or Mrs. Thái Vũ Yên Nhi give no, because two foxes act on a different body. Surely they act on two different body. Why? The rest, if you give the correct the answer is correct. Okay, but why? Some minutes before, you say that fox system as a system or is a system of foxes acting on one rigid body. But here you see that I have two foxes on two body, so they cannot create one fox system. So it is nonsense to speak about the equilibrium. Okay, do you understand? Well, but the second portion I say, but sometimes I remove it. You see, for example, table on the ground. In this case, I can remove action and reaction of the table on the ground. Why? Why can I remove it? Even they are not in equilibrium, but I can use a second axiom. I use a second axiom here. I remove it. Even, but they are not in equilibrium. Why? Why I can remove it? Oh, sorry. Do you understand? Even I can remove it. Okay, we see, because you see it later. I will give you the answer some minutes later. Okay, sometimes in some case I can remove this action reaction foxes, even they are not, or they don't create the equilibrium system, but somebody says they are in equilibrium. Why you will see it some minutes later. Now you will go to the fifth static axiom. Fifth static axiom. The constraint body can be considered as a free body when it's released from the constraint as subjected by corresponding reactive forces instead. It is one basic tool for you in this static course. Here you see, I have a body. It is not free. It is not free. All the time they are in interaction with the environment, with the ground, under the action of forces. And your task is a creator it free and calculate the reaction forces here. And it can be done only with the assumption that I remove it, I or release it from environment, from the constraint, this support, and instead of this constraint, I have reaction forces. Okay, 1, 2, 3 forces, and this axiom give us the the tool or the way that it is possible, it is valid. But it is only the first step. The second step for you, it is very important for you. How? You can see I have support. 1, 2, okay? 1, 2 support. First one, second one. But you see here that for the first support, I have 2 reaction forces. The second support, I have only 1. Why? And it is the task of the engineer to create the model and so on. And the at the examination, you will fail if you can do it well. So remember well that this axiom all the time. I repeat it many times. Not today, but next time, or next time more. Week after week, you will do it together. Okay, and if you can do it well, so you will fail. You will fail on the final examination. Sixth axiom: the flexible in equilibrium under the action of force system will also stay in equilibrium after hardening or rigidening or after making it harder. What is this? What is this? Here you see that I have flexible. Some minutes before, we say that we have a we have a absolutely rigid body. It means that the body don't deform. Okay, but this axiom give us the tool for studying the flexible body. Okay, so they say that this flexible body under action of some force system, okay, in equilibrium. So in this case, if I say that this flexible is a act or behave exactly in the way of the rigid body, it is a way. Okay, so you see here for rigid body, all the time I know it. I have a rigid body under action of action of force system. It is okay. It's nothing new. However, sometimes I have a flexible rigid body. This one, like a spring. We can have some harder, some cloth or some other body, but it is not rigid. It can deform. So in this case, I have flexible rigid body. But this rigid body is under action of system which create for system equilibrium. So in this case, I can make or I can imagine that this flexible body under equilibrium like a rigid body. Okay, so in this case, I say that this first rigid body, flexible body, sorry, but under in equilibrium under action of some force system. So in this case, I can say that it is a rigid body also. Okay, do you understand? So in this case, come back again to this picture some minutes before. Body A and body B. In this case, if these are two rigid body, if I separate it, so I say that they are two rigid body, is okay. No problem. But sometimes I need to study both one in one system. So in this case, because they are in the system FA, and I can imagine it like in the flexible body, and they are in equilibrium. This is a force system. So I can make body A and body B like one rigid body. So in this case, this so-called hardening or rigidening the whole system. This create also like the free body diagram in the 55th static axiom. The sixth axiom create the tool for so-called rigidening. Very important tool for studying in the axiom. Sometimes I make the system of the all rigid body like only one rigid body. Okay, it means that in this case I take two rigid body like only one rigid body. Okay, and now we go to the unit of a measurement. You see again that we have a length, time, mass, and force. Some minutes before you have already discussed this, and I say that they are not independent. Why? And somebody have already give the where okay. Somebody think why you cannot. Oh, sorry. Why they are not independent? Because you see here, they are not independent because they are coupled by second neutron law. Second neutron law, and in dynamic, you know it. We and uh, they are because they are coupled by second neutron law, the second dynamic law. This second neutron law you will see. You will see. We discuss more in detail in the second course in second semester. But you see that if I define F, I define M, I define A, M a mass, A is a concerning with the length and time because it's a meter per second square. So in this case, the F, I cannot define it in any way. Okay, so you see that here, for example, the international system of unit SI. In English, we call it SI, but normally we call it SE because it is from French language. Système de unité internationale. Okay, I stand for international, international, and S is a system. Okay, so in this case, for system of SI or SE, the three basic unit is a length meter, time second, and kilogram in mass. So in this case, from the F equal ma, I can define F equal ma. So you see that 1 Newton is 1 kilogram time 1 meter per second square. It means that 1 Newton is the unit of force which gives the mass of 1 kilogram, the acceleration 1 meter per second square. Okay, okay. So you see that here it is a system, and you should be very convenient with the SI system. I don't know, Mr. Osama, in Morocco, you use which unit system? This one or another one?
I'm sorry.
Mr. Osama. What?
I'm sorry, sir. Could you repeat your question?
In Morocco,
Yes, sir.
you use this SI system or not?
Yes, sir.
Yes. Okay. So another maybe, so I don't know, because in
Because
Morocco I think that you speak French. Okay, French.
it's a second language. That's why. Yeah.
Okay. So I don't know, but in English speaking country they use another unit system. Normally they say US customary units, but sometimes they call FUS. What is F? F stands for foot, P stands for second. the make of one. Okay, and know that the mm, US customary units, or sometimes is FPS. F stand for again, so for the food. S for S for second for the time, and pow for the fox. And mass is a derived unit. M is what F divided by A. It means that one slug, it is unit of mass, is the mass of the particle which under the action of the force 1 pound has the acceleration 1/5 per second square. Here the sum is missing as a second square. Okay, so you see that because you are in the advanced program, and the course is taught in English, so you should be able to convert from the first first system to the second system. Okay, be careful. Sometimes in the textbook or even in this course, I use I take some example from the second US customary units for you be able to convert it from the first system to the second system. Okay. Next portion for discussion is homogeneity. You know it. Homogeneity. Sometimes it's good for you to check the result. The unit of the left side, and the right side should be the same. If you write some equation, check it by homogeneity of the dimension should be the same. Okay, it is a one way for you to check your result, especially later in the dynamic course. Significant figure, rounding off number and calculation, it is very important. If you remember again, that's last month you have the examination in the quizzes in online, and the machine will make the mark for you. And all the time, it is very important if how many significant figure and how you take a rounding of number of the result during your calculation. Pay attention. Okay, significant figure is any digit including zero, but the location from the decimal point of the number. Normally in mechanics, you take in the result, they require you 3 significant figure. So in this case, it means that during the calculation, each intermediate calculation, you should take four significant digit. Okay, and pay attention also so rounding off number. Normally you use your computer, you use your calculator, and intermediate you write it into your paper. You take so rounding off result, and pay attention, especially if you will continue with the online examination. Pay attention because the machine cannot recognize the result of you. Say for example, if you say gravitational force constant 9.8, and somebody use a gravitational constant like 10, immediately if you take 3 significant figure result, so it leads to the wrong result, and they cannot be calculated in the final result. Okay, so pay attention, read this thing at home, and it is not topic of mechanics, but I only mentioned to you to pay attention to this, because in examination, and if you are continuing in the online examination, it is especially important. Okay, and the last portion before break. I have we have two things in the static. First one, to finding condition for equilibrium, which is theory. You will do together, because we all the time we say the equilibrium of force system, but how we can do it? You can do together. But the second one is a task for you in the problem and homework and examination, and also in your future is is the problem of engineer to finding the reaction forces in the subsystem equilibrium. Okay, it is a typical, it is typical for you for the examination for okay, here for example this one typical for typical, but too easy. If you have some problem with a given force, and now the rigid body is here surely in equilibrium, and your task of an engineer is specified how large the reaction force at this support and the second support also. Okay, so you see, you should specify the forces in red color. Okay, so determining reaction forces of the system equilibrium is your problem. And now you go to the second chapter, force system. Before, with the force system, anything connecting with the force system, you can study the equilibrium and so on, and the dynamic also. But before going to this force system chapter, you can make a 10-minute break. Okay, so 10-minute break, 10 minutes. So okay, we can continue. Okay, let's continue. I see that Mr. Thắng asked someone tell me what is the second mind problem. My problem is the problem of the static. Okay, I don't know what your problem is alive or somewhere, but the problem in the static for the student for engineer is is calculating the reaction forces. Okay, normally because all reaction forces is support and even somewhere in the structure and somewhere you have a given force, and your problem is calculating the to calculate the reaction forces, and you will see that the structure is good enough or not, or it will be destroyed or it will be broken also. Okay, so and now in this chapter you will see there are many axes, but main thing is to calculate the force system and calculate two things: resultant force and resultant coupler, resultant moment. So you should be able to calculate the moment, okay, about an axis or about a point, and with this to calculate the force resultant force and resultant coupler, and use this with these two things, resultant force and resultant moment. You can reduce the whatever complicated force system to the simpler and the simplest one. And after reduction of the force system, you will define if the system is in the equilibrium or is in the motion. Okay, so yeah, in the force system chapter, you will have this is the main topic. The first one, you will do something with the force vector, because with the vector definition of the force, you can do many things. You can do many things with the help of the mathematical operation. And after that, you can calculate two things: resultant force, and resultant coupler. Okay, but for calculating resultant coupler, you should calculate the moment of a force above a point and above an axis also. Resultant cap and resultant force. With resultant force and resultant coupler, you can do reduction of a force system, what you have already said. So here it is the main task. Today, you will do with the force vector and resultant force, but for some simpler cases. And after today lecture, you can do some example at home, and the next portion you can do in next week or week after week. Prepare well for the quiz and all the time. Okay, so force vector, what is this? You know that vector can be represented by a point of application and magnitude and direction, like other physical quantity in physics and anywhere in engineering. You see that you have two kind of quantity: scalar and vector. Scalar, for example, mass, volume, length, temperature, for example. It is also uh, scalar. And other time, this scalar can be represented by only one number with the sign positive or negative. But in comparison with scalar, vector is a more, we have more information. Beside of magnitude, they have also direction. Sometimes they have a point of application also. Okay, so for example, in static, we have beside of force, I have position, I have moment, I have acceleration, I have anything. I have, for example, linear moment of linear momentum. Later you see it. Okay. Angular momentum, sorry. Okay, for but later today you see that for physical quantity you have either scalar or vector. Okay, how you can represent the vector? It is a very useful when I use it with the fox. Normally, a vector can be represented by using so-called geometrical representation with the arrow overhead over this letter, like here. I have a vector A, and with the arrow with the vector over this letter 8. For computing time, especially at this time, you use so-called algebraic or a matrix form of representation you see here. I write the letter, but not in a normal way. I write in boldface way. Okay, so it means that I have a vector 8, especially is textbook using the computer and computing. Maybe if you go to some computational mechanic and other like informatic, and also so the symbol in boldface type like here is a so-called algebraic or a matrix representation of the vector. Okay, you can compare geometric vector. You can write it by vector A, okay, with the arrow over this letter. Okay, it's too slow, too slow. And in the algebraic vector representation, sometimes in textbook they call matrix form. You will have A right here. A have two components, AX, AY, and AZ. All the time it connected with some coordinate system. Normally, in the matrix form and algebraic form, you write it is a column vector. It means this vector is in the one column. However, it requires a space. So better in the textbook, write it in one line, one row. So I write AX, AY, and AZ, three components, and with the T transform operation, transpose. Okay, it means that normally it should be column vector, but I write it in one row, so I use a transpose form. AX, AY, and AZ. So it means that in algebraic vector here, it represents the geometric vector here, like by using unit vector I and J and K, and vector 8 in geometrical representation can write AX times unit vector I, AY times unit vector J, AZ unit vector K. Okay, so it represents, but if I use an algebraic vector, it is enough if I write I. Also, I imagine that it have three components, AX, AY, and AZ. One comment, one note for you, that scalar in our in our course or in textbook, you use italic time. Okay, italic letter like here. A boldface A, it is a vector A. Okay, but in italic form, it is component. It is italic form. Okay, italic time. So how you can use this vector presentation in for 2D problem in 2D space. Fox F, you see here, I use a boldface. It means that it is a vector, but I have a two component, fx and fy, fx and fy, fx and fy here. Here I represent it by a vector because it is the only component like in parallelogram. Okay. However, if I write in the vector presentation here, I have f equal fx times a, fy times j, or in the vector form here, I have only fx and fy. Okay, in the vector in one line, but normally it should be column vector. All the time they connected with some coordinate system. For 2D, I have x and y axis, and it means that unit vector I and j. And in this form, I can calculate the magnitude by using Pythagorean theorem. F equal root square of two components, fx and fy. And also, beside of magnitude, you can calculate the direction. Alpha and beta, the angle of the force, total force F of the force F, with respect to x-axis and y-axis. It is quite easily. Okay, I know the component, I know the magnitude of total force, so I can calculate it very easily by using cosine, or with the two component I use a tangent component to calculate the angle alpha. Okay, the same for angle beta, using the fy and f using cosine, and with tang kind fy and fx. But surely alpha and beta are not independent. They are coupled by relationship cosine square cosine beta square is equal unity 1. Okay. With this, with the direction, you can calculate very important also direction. Unit vector. Unit vector is a vector which show the line or the direction unit vector along for one vector or some line show the direction of this line, but the magnitude of this vector is only one, is unit. Okay, for direction unit vector for vector f, I can find very easily if I know the component fx and fy and the total magnitude f. Or I can use directly angle alpha and beta, cosine alpha, cosine beta, to write directly the unit vector, because you see that the component square gives the unit magnitude. Okay, direction unit vector. But I say that with the foxes, with the unit vector and the vector, you can do many things. You can do the, for example, adding two vector. I can do two fox vector. I can take a subtraction. But one thing very important, for example, I can do projection or projecting f on some line. Okay, if I have fox f here with the unit vector u, and now I want to project fox f on some line. This line has the unit vector ax and ay. Okay, I give some question, maybe interesting for you. So for somebody it is difficult, somebody it is easy. How I can do projecting or projection fox f to the line AA with the direction vector ax and ay. Okay, do you understand my question? How I can project this fox f, for example, In direction x, it is quite easy, fx. In direction y, it is easy, it is fy. However, how I can project it into some direction ax and y. In x, surely it is 1 0 unit vector for y line is 0 1. Okay, but for arbitrary line, unit vector is ax and y. How? I give you 1-2 minutes. I have Fox vector f here, fx and fy. Fx and fy, we have only divided. And now I have a line with the unit vector ax and ay. How I can project it? How I can project it? F. Nobody? Some minute. No answer? It is too complicated? Okay, so it is quite easy. If I have, in this case, I can provide a dot product. Okay, dot product. Dot product of f with the unit vector 8. In this case, I dot product of two vector f, vector 8. So I say dot product, but the total result should be fx times ah plus fi phi ai, and I guess the result. Okay, it is quite easy. It's quite easy. And in this case, fx and fy, as I have decided here, it is so-called rectangular component of Fox f. Here I will do the same for the vector in 3D space. In 3D space, I have a rectangular coordinate system x, y, and z with three unit vector I, j, and k. I, j, and k. And in this case, f can be written like f times fx times I, fy times j, fz times k. Okay. And in the matrix form or algebraic form, you can write it very easily by one vector, algebraic vector fx, fy, and fz in transpose term. And with this, I can calculate magnitude in the similar way by using Pythagorean theorem. Pythagorean theorem, we have fx, fy, fz square and give summation, and after that I have a root square, and magnitude can be calculated very easily. The same, you can calculate also the direction. I calculate the direction of the f. It means that I calculate the angular alpha, beta, gamma of the Fox f above or each respect axis x, y, and z. So three angular alpha, beta, and gamma. Surely these three things are coupled by this relationship: cosine square alpha, beta, gamma. Summation is 1. Okay. So again, we calculate the unit vector for this Fox. Because I know alpha, beta, gamma, I calculate fh. So you can use either angular alpha, beta, gamma, or use the component fh, fy, fz, and f and f. Okay. Again, if I want to project Fox f, outline AA with unit vector 8, I can provide dot product. I can provide dot product of unit vector, or if I have vector, I can divide it by this by the magnitude of Fox F. Okay. Here it is a projection of F to the of unit vector I. So one thing, it is very important for students. Many students forget it. I repeat it here because it is very useful for all students, especially in mechanics and in the to calculating. It is so-called right-handed rule or right-handed coordinate system. You see, that I use the right hand, I use the thumb, and other finger, and the system can be defined by X, Y, and Z, or I can say the axis of 1, 2, 3. But it can follow. I say X, Y, Z, X, Y, Z, X, Y, Z, or 1, 2, 3, 1, 2, 3, 1, 2, 3. So how we can do it? If I can take right hand and I show the thumb, and I show also the other finger curling, okay? And I say that if my finger show the curling from the positive direction of the first axis, in this case the x-axis, to the positive direction of the second axis, in this case y-axis, curling from the first axis to second axis, positive direction. So in this case, the thumb will show the positive direction of the third one, or the Z1 in this case. Okay, I remember the curling of my finger, the right hand, showing the positive direction of the first axis or Z-axis to the positive direction of the second axis, okay, to the second axis or Y-axis. So the thumb will show the direction or positive direction of the third one. But you can continue with 1, 2, 3, 1, 2, 3, because I start with the one, so you can start with the second, with the curling of the fingers showing the curling from the second axis to the positive direction of the third axis. So the thumb will show the positive direction of the first one. So you understand 1, 2, 3, 1, 2, 3. So we start with the 2, so we can do the 3 and 1, 3, 1. So it is very important for you to make it and remember when all the time I write right-handed rule or right-handed coordinate system. Following this rule, you can apply it for the two-dimension program. Normally, I say the positive and negative. It is clockwise or counterclockwise. So you see, counterclockwise, it is positive. So in this case, the positive direct, it is outward from the page to me, to us. Okay, and negative, it is clockwise, and it is inside to the paper to you. Okay, so remember when this form using this vector, okay, with the right-handed coordinate system. And now the first example for today. What I say, I have one bracket, the Fox's F here, acting, and now try to find the projection of a component, projection 3 component to the try to component projection of this Fox with 3 component X, Y, and Z to the line OA. Okay, and you can calculate the angular direction anything because I have the dimension on the described on the picture. So some minute for you to make a orientation. That is a hint for you. First, because if I want to find the projection of F to line OA, so I should calculate the unit vector of OA. So after that, I should provide the unit dot product of F times OA. Okay, but you can find also the angular theta F with OA. So I give you some minutes to make orientation. You can do together, okay? So first step, maybe it make some difficulty for you with the imaginations of foxes. Okay, so if you cannot catch the image, and so look at home later. Okay, but very important is a step how we can do it. First, I calculate the unit vector for ROA because I know position of point O, I know position of point A, so I can calculate very easily position vector ROA. So I calculate the magnitude. I calculate the unit vector of ROA. Okay, this clear? Next time, you can calculate the component of Fox F. Maybe it may give you some difficulty, but don't be confused. Don't be set up. Take it easy, okay? You can do it. F, three component of F. If you know the position, you can you can project it. F will have two components. One is along this line, along this plane, and after that you can find it very easily. Okay. So with these three component of F, I provide a dot product. If you provide dot product directly with the unit vector of OA, so it gives the projection of F. Or if you provide it to the with the position vector ROA, so you can calculate the angle theta. Okay. Here you see that if I write directly the unit vector, so you can find very easily the the projection of F along ROA. The conclusion is very more important. If you cannot catch because you cannot imagine more clearly about Fox F, how it can be. But in importance that all the time, remember well that using the component of F in X, Y, and Z, and calculate the unit vector of the line where I want to project the Fox to. Okay, in this case, ROA. And after providing the dot product, so I can get the projection. It is only one simpler example, example for you to see how we can use the mathematical tool when applying to the Fox vector to get the result for later or the future using in the mechanics. Okay. Now, and the same for the projection, you can use for example adding two Fox vector, okay, subtraction, and also another things, or even the cross product. Later you see that if I want to calculate the moment of a force above a point and above a point or an axis, you should use a cross product. And these are three component of each force is very important. Okay, so it is only a simple example using the mathematical operation when applying to Fox vector. And now you will go to the more important things. As we have already said, that one thing for static course, that you should, for theory course, you should calculate the resultant force and later resultant moment also. The first thing, you want to calculate the result of many forces, but in this case today you will do only with resultant force of concurrent forces. Concurrent forces, it means that the forces which intersect each other or they meet at one point. Okay, here for example I have F1, F2, and F3, and they are intersecting or intersect or they meet at one point here. And here, if I apply the parallelogram step by step, F1 and F2, so I can get one force instead of one F2, and the new force I apply it on F3. So I see that these three forces, I have only one result. From this, it has the name resultant force. But how we can do it? We can do another way. I can take one force here, F1, parallel, I fix some point here, point A. I draw parallel line and bring F1 here. And after that, at the endpoint, on the second point, I draw parallel line and I bring F2 parallel here. And at the end, I bring F3 also. And at the end, the line close this polygon. It is the FR, resultant force of section 1. And this picture is so-called polygon. Okay. So you see again, concurrent forces, a set of forces which all pass through the same point. A set of concurrent forces applied to a particle may be replaced by a single resultant force, which is a vector sum of the applied forces. Some minutes before, we have already shown or proved that really this set of concurrent forces can be replaced by only single resultant force by using either parallelogram or drawing this diagram, what I have already done here. Okay, but you can do it by other thing, by using the sum of applied forces, because the force is represented by the vector, and I can use it. You can show it by summing of the all component. But here is the other conclusion. Vector force component, 2 or 3 forces, can be some effect at a single forces. You see here on this picture, 1 force or 3 forces can be 3 forces, F1, F2, F3 can be replaced by 1 FR here. Or here on this picture, F1, F2 can be replaced by only 1 force by using parallelogram. We have already shown it. Okay, and also the force, vice versa, the force can be resolved into 2 or more forces. Okay, 2 or more forces, you see. But this resolving has many results. You see here, 1 force F here can be resolved by 2 forces, F1 and F2, on the left side or left picture, or in the right picture, another F1, F2. So you see that 1 force can be resolved by 2 components, or many forces can be adding by 1 forces. It is the first conclusion. But it is better to do. How to do it? It is better to do with the calculation. Say resultant force of several concurrent forces. How we can do it? If I have a system F1, F2, F3, and Fn. Okay, each force have 3 components in X, Y, and Z with unit vector I and J and K. You see here, I have concurrent forces F1, F2, F3, and each forces have 3 components. So in this case, I can find resultant force very easily by provide summation of all forces F1 plus F2, F3. There are 2 ways to do it. First way, in drawing method. I can drawing polygon of forces by applying the parallelogram or step-by-step parallelogram also. Okay, the first thing. It is this picture. You can draw it like here. Okay, it's too slow. Or step-by-step with the parallelogram. But it is better to use a projection method. It means that I project all the forces into 3 components here, X, Y, and Z, and adding all these components separately in X direction, in Y direction, and in Z direction also, and the resultant force will be with 3 components like here. Okay, So it is better for calculation. Here we can make some with this you can calculate the magnitude and the slope, the angle also. Three component you can calculate, specify very easy by Pythagorean theorem. Pythagorean theorem, okay? And the direction you need vector by using the component and the total force, or by using also the angle alpha beta gamma, quite easy, okay? And we have some if I have provide adding two forces, you can use algebraic using the computation like a previous slide, or you can use a parallelogram, okay? In this case, first thing, you draw parallelogram. Second one, you can use a trigonometry by using sine and cosine law, okay? If you draw the picture using geometry, so you can use the sine and cosine law. Sine law, cosine law, it is quite easy for you. So it means that if I thought really if you draw parallelogram, so this one is a half of the parallelogram, and I use a sine law and cosine law to calculate it. In the small textbook, it's a problem. You can have the many example. You can do it by using geometry like here, trigonometry, or using the adding it in the x, y, and z direction. Two way, each way you do it. Okay. And now you go to the example. Last one. This one is two dimensions, so it is better for you to see what happened. I have three forces: F1, F2, F3, and try to find magnitude and angle of resultant forces. This one I give you more time. Maybe it is better for you that it is not complicated imagination like in 3D problem. So do it. I give you some minutes. Here is a plan. Resolve the forces into two components, into two axes, x and y. And after that, provide what I say is a summation in each direction separately. And after that, calculate the resultant force. And with the resultant force, I can find magnitude and angle from component and resultant. Some result, I wait 3, 4, 5 minutes. So, no results. First, because first force is in y direction, so surely that the component in each direction is 0. Okay, first force. Second force, who cannot check it? Somebody have already left. We will check because the team will make a present roll call. And after only at the end, all the time, many students who are very lazy ask if they can give the permission to go to the examination, or please raise me the score or something like this. But they are lazy. You will see it. Why? Have two components. The second component, again, attention with the angular negative sign. Third one. With these three components, we calculate the summation. We calculate the summation of these three forces. Summing up all the component in x and y, or in the I and j component respectively, we get. So with these things, you can calculate very easily the magnitude and also angle, in this case phi. Okay. This is the result. Oh, sorry. This is the result. Okay, this is the last example. And now some conclusion today. Tomorrow, I will show up or post the portion of the text in the team, so we will read this textbook, section 2.2. Surely you can read the first one also. It is better for you, but read the example also. Study and start to do some problem with the small textbook. For somebody who join my course already in other course, you see that it is very important for me and for you, because I try to recognize you also, that you should send me solve problem. Okay, and all editing of your activity during your participation on the course, your activity on the course, and the homework will be will be represented in your score, midterm score. Okay, and prepare well also Thai for the quizzes, because I don't know what happened with the COVID next time, but if you have time, we will have the first test immediately. Okay. And when you send me the problem, please send me only one file. If you have more example, please compress this in only one file. Okay, and send me, and in file or in email, by email. Okay, and send by email, and in the title of email, please specify your name and the problem, the name of the problem. Okay, one file and the name of the problem. Okay, Have you any question more? 2 minutes more. If no, I hope that you enjoy the lecture, and next time you will see in the complete complete all of you. Okay, if you have no question.
Sir. Hello, sir.
Okay.
Sir.
No question. Okay.
Sir.
So
Sir.
no, I cannot hear you well. Okay.
Teacher.
Okay. Please. I I cannot hear anything. Okay, so if you go, okay, so see you soon. Hello, okay, see you soon. Okay, bye bye.